Hey guys, Tiny Maths here, back with another video helping you with your maths journey one step at a time. Today we're going to learn about prime numbers. What is a prime number? How does it differ from other numbers? Stick around and you'll find out. Before we begin, there are 2 points you need to be aware of. Firstly, prime numbers are part of the natural numbers, that is, whole numbers greater than 0, from 1 to infinity. It's in that list of numbers that you will find the prime numbers. That means that there are no prime numbers that are negative. Whenever I talk about numbers in today's video, I only mean positive whole numbers, the natural numbers. The second point is that all numbers greater than 1 are divisible by at least 2 numbers. We're not including the number 1 here because it is only divisible by one number, itself. Try to divide it by any other number and you get a fraction, not a whole number, and that's not a natural number. So 1 is only divisible by one number, itself. All of the other numbers are divisible by at least 2 numbers. They are divisible by the number 1 and they are divisible by themselves. All of the natural numbers absolutely must obey this rule. The majority are divisible by more than 2 numbers, but none of them can be divisible by less than 2 numbers. The bare minimum is that they are divisible by themselves and divisible by the number 1. And now we can talk about prime numbers. Prime numbers are natural numbers that are divisible by exactly 2 numbers. Now, since we saw that all numbers greater than 1 must, as an absolute minimum, be divisible by 2 numbers, and that those 2 numbers have to be the number 1 and the number itself, and no number can escape this rule, then if you have a number that is greater than 1 and it is divisible by exactly 2 numbers, those 2 numbers must be the number 1 and the number itself. So prime numbers are only divisible by the number 1 and themselves, and that's what makes a prime number. We say the number is prime. Today we'll look at the first few prime numbers. Now, since the rule is that prime numbers are divisible by exactly 2 numbers, oddly enough, the number 1 cannot be prime, since it is only divisible by one number. That's the number 1. Now let's look at the number 2. 2 is divisible by 1 and by 2. Dividing 2 by any other number will result in a fraction, not a whole number. So there are only 2 numbers that can divide the number 2, the number 1 and 2 itself. So 2 is prime. Remember, we're only talking about natural numbers here, that is, the positive whole numbers. Let's try the number 3. 3 is divisible by 1 and by 3, and again it is not divisible by any other number, so 3 is prime. Try this for yourselves. Try to divide 3 by a number other than 1 or 3. You will end up with a fraction. So the number 3 is only divisible by exactly 2 numbers, 1 and 3. So 3 is prime. What about the number 4? Well, yes, 4 is divisible by 1 and by 4, obviously, but you can also divide 4 by 2, which results in a whole number. So 4 is divisible by 4, 2 and 1. That's 3 numbers. So 4 is not prime. What about 5? Well, 5 is divisible by 1 and 5. Try and divide by any other number and it will result in a fraction. So 5 is prime. 6, on the other hand, is divisible by 6, 3, 2 and 1. That's 4 numbers, so 6 is not prime. Why don't you try a few numbers for yourselves? I'll give you a few. Try 7, 8, 9, 10 and 11. Pause the video and see if you can find out which of these is prime and which is not prime. And while you're scratching your head trying to figure this out, why not smash the subscribe button, hit the notification bell, and of course like the video, so the YouTube algorithm can know that these videos are appreciated and recommend them to more people learning maths. Well, 2 out of that list of 5 numbers is prime, 7 and 11. The rest are not. By the way, any number that is not prime is called a composite number. That's any number that's divisible by 3 or more numbers. 4, 6, 8, 9 and 10 are all composite, and 2, 3, 5, 7 and 11 are all prime. So now you're in a position to at least start trying to figure out other prime numbers. You can probably find a list of the prime numbers anywhere on the internet, but there are some interesting things about the prime numbers that might help you work out at least the prime numbers between 1 and 100 without memorizing. Here are a few ideas. So let's start with one interesting fact. The number 2 is the only even prime number, so all other even numbers are not prime. Why is this? Well, let's think about what an even number is. A number is even because it is divisible by 2. But if you think about our earlier rule that all numbers greater than 1 are divisible by a minimum of 2 numbers, the number 1 and themselves, and that applies to all of the numbers greater than 1, even numbers have an additional property. They are also divisible by the number 2, on top of the fact that they are divisible by themselves and by the number 1. So even numbers must be divisible by 1, by themselves, and by the number 2 because they are even. That's 3 numbers. So except for the number 2 itself, which is prime, all other even natural numbers are divisible by 3 numbers and therefore cannot be prime. Another way of saying it is that any multiple of 2 except 2 itself cannot be prime. So we can therefore say that 2, 4, 6, 8, 10, 12, 14, etc. all the way up to infinity are not prime. So really, we've already eliminated half of the numbers between 1 and 100 because half of them are even. This idea works the same for the prime number 3. Any multiple of 3 except itself is not prime. The same principle applies. Any multiple of 3 that is not 3 itself is divisible by the number 1 and the number itself, which is already 2 numbers, but it is also divisible by the additional number, by the number 3, because any number that is a multiple of 3 is obviously divisible by 3. So none of these numbers are prime either. So now you can eliminate multiples of 3 from our list of the first 100 numbers. Careful though, because some multiples of 3 are also multiples of 2, so you would have already eliminated them. But I think that amounts to about 10 numbers, so already you've got rid of 60 numbers from the first 100 numbers. You can repeat this process with the multiples of all the prime numbers. So with the exception of the initial prime numbers, all multiples of 2, 3, 5, 7 and 11, etc. are not prime. If you cross out multiples of each of these primes that lie between 1 and 100, you would end up crossing out most of the first 100 numbers. The very few left would be prime numbers that are less than 100. There's a name for this process actually. It's called the sieve of Eratosthenes. Make sure you're subscribed because I'm going to do another short video showing how this process helps you find prime numbers more easily, especially prime numbers that are less than 100. Anyway, it's safe to say that if you can find any number that is divisible by a number other than 1 and itself, it cannot be prime. So if you find just one number between 1 and your main number that is able to divide the main number, your main number cannot be prime. Here's a few quick examples. 35 is divisible by 1 and 35, but it's also divisible by 5. You don't need to go any further because that's already 3 numbers, so it cannot be prime. What about the number 93? Again, that's divisible by 1 and 93, but it's also divisible by 3. You already have 3 numbers that divide 93, so it cannot be prime. What about the number 23? 23 is divisible by 1 and 23, but you won't find any number between 1 and 23 that divides 23. So 23 is prime. So there's how you know if a number is prime or not. Today's video was the first in a series. Actually, I've made one of the videos already and I've linked to it in the description, and we'll link to it here at the end of this video. But in the rest of the series, I'll be showing you how to use prime numbers to do prime factorization. That is, how to write numbers as a product of prime factors. Also, how to find the highest common factor of two numbers. Also, how to find the lowest common multiple of two or three numbers. And finally, how we use prime numbers and prime factorization when simplifying fractions. So again, make sure you're subscribed and have clicked the notification bell so you can know when I'm releasing a new video on this series. Well, that's it for now. Thanks for watching. Until the next video, take care.